Hello guys, in this video we are going to be discussing the Leetcode problem single number 3. In this problem they have given us an integer array nums in which exactly two numbers appear only once. So for this particular integer array nums 3 and 5 appear only once, and the rest of the numbers that are 1 and 2, they appear two times. So in every array that they give us, only exactly two elements appear once and all the other elements appear twice. So we have to find these two elements which appear exactly once. So for this problem we are going to be using uh, the bit manipulation, or the bitwise operation, or sometimes called binary operations. So some of the properties that you need to know, some of the properties that you need to know to solve this particular problem, I'll explain those properties. One property is that a suppose a is some random integer, a XOR a will give you 0. XORing the same number will give you 0. Why is this? This is because of the inbuilt property of XOR. What does XOR do? XOR, if they are if the same bit has the same value, it will become 0. If the same bit have different values, it will become 1. Likewise, if the same bit has different values, it will become 1. If the same bit has same value, it will become 0. Okay, this is the same bit for two different numbers, right? So this is the, suppose the ith bit for the element a, and this is the ith bit for the element b, and since they are both equal, the resulting bit will become equal to 0. So since uh, a are equal, so all the bits in A will be equal. So all of them will get become 0, and the resulting answer will be 0. So that's one property that you need to know. So what we are going to do here is that for this particular array, we are first going to compute the total XOR. We are going to compute the XOR of all the values. After we compute the total XOR, inside this total XOR, since the same values will get cancelled out, only the unique values will remain. So the total XOR will basically be the XOR of the both the unique values. So for this particular nums array, total XOR will basically be 3 XOR 5. Now one interesting thing to note is that now since for both 3 and 5, since both of them are different, at least one of the bits in the total XOR will be equal to 1. At least, at least, at least one bit in total XOR will be equal to 1. What is the opposite case of this? What is the contradicting case of this? All the bits, all the bits in total XOR is equal to 0. When will this case happen? This case will happen when all the elements are equal, but they have said in the question that the two elements will be different. So exactly two elements appear only once, and uh, this will be different. Like actually they haven't specifically mentioned that, but we can deduce from the problem statement, right? Like we can deduce from the logic of the question. So since those two numbers, two unique, the two numbers which appear exactly once will be unique and not equal to each other. At least one bit in total XOR will be 1. So we have to find that position. So that we have to find that bit. So I am iterating. So I am iterating from 0 to 31. So these are the bits. So basically, so since they have mentioned that the value will be 2 raised to 31 minus 1, so I am iterating from basically 0 to till 31, not including 31, and I am checking for all bits with whether that particular bit is 1 or not. If that particular bit is 1, I am setting the position as I. So I is the current bit which is not which is equal to 1, and I am breaking this particular for loop. And now what I'm going to do is that since this particular ith bit is 1, since this ith bit is 1, we know that suppose the first unique element is a and the second unique element is b. So we know that the ith element for if the ith element for a is equal to 0, then the ith element for b should be 1. Then and only then will the XOR of 0 and 1 will be equal to 1. So, and the other case is if the ith element for a is equal to 0, then the ith element for b should be equal to 0. Ith element for a is equal to 1, then the ith element for b should be equal to 0. So what I'm doing is that I am uh, initializing two variables 0 and 1, and inside this 0 I am taking the XOR of all the values which have the ith bit as 0, and inside here I am taking the XOR of all the bits that have the ith value as 1. And after we do that for all the values, inside this 0 will be the first unique element, and inside this 1 will be the second unique element. Now you will ask me, what about the other elements that we are adding into this particular 0 variable and 1 variable? So if okay, so suppose 0 is equal to a no, suppose a is the one which have ith bit as 0, and b is the one which have ith bit as 1. So 0 will be equal to a XOR a some ai, so nums I XOR some nums j XOR some nums k XOR some nums p. Now it will be, so I told you already that after performing this all the operation, 0 will be equal to a, right? Then what about these other values? These other values will get cancelled to each other, because like since we are taking uh, all the values which have the ith bit as 0 in this particular 0 variable, uh, we so if I take this particular nums of 5, so nums of 5 will have uh, the ith bit as 0, then we will also take its duplicate as well. So either this nums of j will be its duplicate, either this nums of k will be its duplicate, either this nums of p will be its duplicate, because its duplicate also have the ith bit as 0, right? So it's not logical, like logical where we take one element of the duplicate and we ignore the other duplicate. No, since this duplicate will also have the ith bit as 0, and the other duplicate will also have the ith bit as 0, we will include both of them in this particular 0 variable. So After computing all the iterating through all the values, the 0 will be equal to A and 1 will be equal to B. This is the case where A has ith bit as 0 and B, okay, what is this ith bit, right? Not the ith element. Then the ith bit, so B has the ith bit as 1. So that's for that case. So that's what we are doing over here. So if the ith bit is 0, I am XORing it to 0. And if the ith bit is 1, I am XORing it with 1 and I am returning 0 and 1. That's basically the code. I will submit it and show it to you. Yeah. So the time complexity and the runtime and the space complexity is very good. And we are also using OFN time complexity and OF1 space complexity as mentioned in the problem statement. So yeah, so if you have understood the problem, can you comment down below whether anything like if you haven't understood the problem, can you comment down below whether what can I improve in the future videos and how can I improve my explanation further so that I can make better videos in the future. Thank you.